So I'm going to actually tag team this with Joel Dulacey. So again, my name is Chris LaPointe. I'm VP of Product Management. I run the product team reporting to Denny. I was actually the second product manager brought into SolarWinds back in 2006. So, like Denny, we kind of shuffled products and were responsible for product managing a lot of the early products. Obviously, as we've acquired them, we know less and less about those. But the one product that I did want to talk about is NetFlow Traffic Analyzer and kind of some of the things that we're doing there. So I'll talk about that in a second, but first I'll let Joel introduce himself.
So I'm Joel Dulacey, and I'm the CTO for SolarWinds. I've been here for 7 years now, and so I'll go and kind of do some deep dive into NetFlow and how we are solving some of the problems that Chris is going to talk about. Kind of show you some of the technical details about how we're going to solve those.
Sure. So first of all, I want to make sure that everyone knows what NetFlow Traffic Analyzer is, and I think hopefully the name is sort of self-explanatory, but it is our traffic analysis. Who is using the bandwidth, and what are they using it for? Product, and it goes hand in hand with our flagship product on the networking side, Network Performance Monitor. With NetFlow, SFlow, JFlow, collecting all of that is a ton of data. So for those of you who have turned on NetFlow on the network and actually used Wireshark and actually saw the amount of traffic that flow data that was actually being generated on a high-speed link, you'll sort of know what I'm talking about. So as we built the product, we decided to build it on the Orion platform, which made perfect sense. And I'll actually kind of draw what I'm talking about as I go, so that way, and then Joel can tell you how this is wrong and this is how it really works. But I'll start with big animal pictures, and then he can draw on the details. So we have NTA, we have the Orion platform, and then somewhere in here, again, Joel, give me a little bit of liberty here. So there's a box called the collector. Right, and so that is where all of the flow data comes into, right? And so the question is, okay, now where do we store that? Well, today we store it in the same SQL server that all of our other data is going into. So that presents a little bit of a challenge for us. And so we've been working for the last 3 or 4 years to optimize that, to figure out ways to better collect the flow data and make sure that we're only storing the stuff that really matters to the troubleshooting scenarios. And we've actually gotten to some pretty incredible rates. We have customers that are running 150,000 flows per second at peak, 75,000 flows per second, sustained. So that's pretty good. But the question is, what size SQL server do they have to set up, and how hard was that? And do most of our customers actually really have that type of hardware and expertise to tune a SQL server for that level of I/O? And the answer is as Denny described, is no, because we're trying to serve a broad base of customers. So over, I would say, about the last year and a half, we've been working on a solution to this problem. So number one, how do we solve the issue where, as you're trying to write all this data to the same SQL server that's supporting all the other products, how do you not affect the performance of those products? Right, and the response time, the things that you see on the website, how long does it take to load, all those kinds of things. Number two, how do you retain that data for as long as our customers want to retain it, right? So if you're interested from a compliance perspective or a troubleshooting perspective with retaining minute-level granularity on your data, and so we can retain that data as long as you have the space and you tune your SQL server. A lot of our customers don't want to go through all that effort, but they still need to store the data. So how do we solve that problem? And then thirdly, how do we enable ourselves to add new features that require extending out this database table, right? So within SQL, we have database tables that reflect, the flow data. And as we add new fields, that also obviously has implications in terms of performance and, the write speed, how long it takes to get data out of this database. So how do we allow SolarWinds to add features to the product faster is basically what it comes down to. without having to worry about all the implications on performance. So the solution, and again, we've been working on this for the last, probably a year and a half, talking about it for kind of a half a year in planning, and then actually going and executing it for about a year, is at least for NTA, to store the data into something different. So I don't know, how many of you, just by show of hands, have heard of Fastbit? I would be surprised if any of you have heard of it. So it was originally developed to support a high-energy physics project called STARS. So if you're interested in high-energy physics, whatever that means, and the STARS project, you can look that up. But the net is that they were dealing with a lot of the same problems we were dealing with on the network side in terms of the amount of flow data and the I/O rates that we were trying to address in terms of building our product. So we've looked at Fastbit, and the goal is to make this transition as seamless for our existing customers as possible. And that's why it's taken so long for us to go through this process. We're actually in beta right now on this transition in this product. So I'll kind of turn it over to Joel now so we can talk about, what does Fastbit give us? Why is that, a good solution for us in terms of the next generation for NTA? And how do we solve some of the problems I just described? Joel?
Yep. So going back to, I think Chris said the context perfectly there. So basically, what we have to solve are three major problems. We have to store data the most efficiently possible with using the least amount of space. We need to be able to access that data very efficiently. And when you look at the amount of data that we actually have to be able to search, the search domain is very vast and requires a lot of space if you want to do that efficiently. So we are kind of in this kind of worst case scenario where we have a lot of data, we need to kind of search it very efficiently, and we can't use a lot of memory. So it's kind of this difficult problem to solve. The third one is scale. We want to be able to scale so that not only do all those flows go to one server, but ideally we want to be able to have point of presence around the enterprise and basically get the local traffic being received there, and then be able to kind of report on that data that's been accumulated and federated across the enterprise. So we've got those three problems to solve. So the first thing is I want to talk a little bit about storage. And how many of you are familiar with NetFlow and what a NetFlow flow is? Okay, perfect. So what I'll just draw here is basically kind of the canonical representation of a flow where you have a tuple or tuple. I'm French, so I don't even know how to say this word in English. So basically you have 7 values. Okay, perfect. You have 7 values that actually you're putting together next to each other that are identifying the different attributes of that flow. And that's the interface index. You've got the source IP. You've got the destination IP. You've got the source port. You've got destination port. And then you've got a bit of other junk in there that really I'm not going to talk about right now because it's not necessary for this discussion. So if you look at this, the other important piece at the end of this is the number of packets that were involved and the number of bytes that were involved into this flow. So when you look at this, the way NTA works is basically as you're exploring your flows in the product, you are basically slicing and dicing those flows across dimension that represents those different attributes. And basically what you're doing is you're fixing, okay, I'm interested in all the traffic that's coming from this source IP and that's targeting this destination port on this destination IP. So there I fix basically 3 attributes, and then I'm looking for all the traffic that match that criteria. The problem when you do that is you're basically looking at, if we take only 3 of those dimensions and you represent the problem space, you're looking at a cube basically in 3 dimensions. And basically the more dimensions you add, it adds dimensions that is just difficult to write. So that's why I'm not going to go with more than 3 dimensions. So if you look at this and you look at source IP, destination IP, and then destination port, for instance, you're looking at trying to find in here, define a subset of that traffic that basically will match your search criteria. Okay? When you do this in SQL, it's very task intensive because it requires the database to actually do a lot of seeks and do a lot of kind of aggregation in memory to try to find the values. So it's actually very inefficient to do that in SQL. And actually what they've solved in the business world, they've used, you're familiar with OLAP and OLAP cubes and OLAP technologies. Well, for BI, they've solved that problem for all that type of data by relying on two different data structures and different type of databases to store and really fast and quickly get you answers about, I want to know the sales for this quarter in this region with this sales guy. And basically you can very quickly go and slice and dice the data. Basically what we're trying to do right now with NetFlow and Fastbit and this change, we are basically kind of applying the same concept that they did in business intelligence for networks analytics. That's really what we're about. So one of the first thing that you do is you look at the storage aspect and look at how does a database store data. So if we take this and let's say that we have a few records, and let's say we have interface 1, source IP, 10.1.1.1, destination IP, 192.168.6.2, and then port, 1, and port 2 destination, and so on. And then you've got a second record that's basically 10.1.1.1, another flow here that targets another machine, 168.6.1, 2, 3, and so on. Well, how does a database represent this on disk? Okay, it takes this record, puts all the values next to each other, and then sequentially after that you got the second record. So that means that if I'm doing a query where I'm looking for all the source IPs, I end up with a lot of seeks, or I end up with loading a bunch of pages in memory into that SQL server to actually kind of get me all the little pieces. So the first thing we do is we look at another technology, which is basically called columnar storage. And I don't know how many of you are familiar with that term, but basically, instead of storing the data row-wise, you're storing the data column-wise. So instead of looking at this record like this on disk, and then this one being appended to it, the way it looks like, you store basically the data in column first. So basically, you're going to have a file that basically will represent on disk, just go back to this, that will represent all the values for instance, the IF will have 1, 2, and so on. That will be basically all the values that are representing that column will be stored very close to each other. The advantage you have with that is you have what's called local, reference, basically, or reference locality, which basically means that the data that is semantically together resides very close to each other on disk, which means that I have very quick access to values that are related to each other. That's great, but the next step after that is that those values are related to each other, which means that I have a very high likelihood that I can compress those values a lot better than if I have to look at a bunch of data that basically are representing different things and that are basically kind of interleaved with each other. Here, if I have 1, 2, and then I have another flow here, and then another 1, 2, and then a bunch of 1 here, there's a bunch of algorithm compression scheme that I can use to actually kind of compress that data a lot better. Once I have basically all those files, I have another one for the source IP, where I'll have all the values, and then I'll have destination IP. And so if you look at basically, if you take a vertical slice over all those files, I've got one record. Once I have that, we need to basically access those files and that data very quickly. So the thing that we need to do is we need to have a very high performance, a high performance indexing scheme on top of that data, so that when we do queries, we can actually get to that data very quickly. And that's where Fastbit comes into play. Fastbit is basically a library that implements a special type of index called bitmap indexes, and that basically it does that very efficiently. There are a few patents about how to compress those bits very efficiently. And so what is without going too much into details, a bitmap index is basically something that maps a value to a location in the database. And typically the location is some type of row ID or some row identifier that allows you to go back from the index inside the database. A bitmap index doesn't do that. A bitmap index just say, okay, every position in that index, the position in the index itself represents the record location. And then I'm just going to have a 0 or 1 to show if this value is present into that record and for that column. So basically I have a series of 0, 0, 0, 1, which basically in this case means that if that's the source port, for instance, here, the value 2 is not in the first record, but it's in the second record. It's not in the third one, it's in the fourth one, and so on. Once you have that, you can compress all those 0 and 1s very effectively. Because what happens is you've got a lot of what's called spare parts in there where you're going to have a lot of zeros next to each other and a lot of ones to each other. Well, guess what? All those things, you can compress them very effectively. And that's what Fastbit does for us. So now we have efficient storage. We can compress all the data. We have efficient access, basically, with this. The great thing also is for queries and the type of queries that we're interested in, they imply a lot of Boolean logic. We do a lot of OR and ANDs and things like that. And guess what? If I'm trying to actually validate, where, for instance, where 2 and 3 are located, and I've got a bunch of, a lot of string, I've got 2 strings, basically, of bits. And so if I'm trying to look at, give me all the records that contain 2 and 3, well, guess what? It's an AND of those 2 strings. And that's very efficient. If there's one thing that computers are geared to, is to do a lot of bit operations very fast. And so that's why it gives us the type of speed that we need to actually do a lot of the queries. The last thing is scale. And one thing that we want to be able to do is, going back to that concept of data locality, what's very inefficient in a lot of systems that are based on a central storage is the fact that you end up marshalling and transporting a bunch of data. That's going to be a nightmare here with the. Okay, so what happened in this scheme is, if you look at this flow, okay, this is great because I've got one central point, of control, and all the data is always flowing to one database. If we are moving, this database and replacing it for the flow information with Fastbit, it's great because we take advantage of the storage optimization, the data access optimization, but we still aren't able to scale by putting a lot of things where the data really is in your network. And so one of the other goals that we have is we really want to have the concept of federation, where you'll have an NTA collector in one place of your environment, another one in another place in your environment, and so on. And then have what I will call the main Orion server. And the idea is that the main Orion server is your location of truth for all the configuration data. So that's where you go to know the list of nodes, the list of how those nodes are configured, what credentials to use. But the data collected by NetFlow stays at each of the NTA collectors. And the idea is there's really no need to transfer all that data back to a central server, because the only thing you do is you basically are putting a lot of load onto one single point of potentially failure. And that's usually not a really good design. And so what we end up doing is, that would be a typical distributed system where, all the remote nodes are kind of, communicating back that data to the central node. We're kind of moving more into a federated model, where the federation means that those entities here are really, kind of autonomous, and they know the data that they have collected. And so what we are working on is we have a way now to basically route queries to the appropriate data collector that contains the local NetFlow data. And basically behind the scenes, the user doesn't need to know that that data is collected on this server or that server. Behind the scene, we are able to basically kind of route that query automatically to the appropriate network collector that connects that contains that data, retrieve the information that needs to be displayed, and then move on. And that's kind of a better model for us overall, because we are not requiring a monstrous database or a monstrous file server to actually hold all your data of all your network. We are basically kind of breaking this responsibility across a multitude of smaller servers that basically can just be added to your environment and kind of grow along with the rest of your traffic. That's all I had for you. I hope it wasn't too detailed and that I didn't lose you.
Quick question. Yeah. Is anything going to change with the collector licensing model? So that
that's for him.
You get all the good ones.
Yeah, I do.
Because if I'm paying for unlimited ports, endpoints, whatever, but I can only collect it to one server.
Yeah, no, that's
Kinda
a great
kills
question.
me.
So I would say the answer is no. Nothing is going to change with respect to the licensing. So if you own an NPM, let's say SLX, which are unlimited, and you have an NTA for that NPM SLX, nothing is going to change with respect to the licensing. So if you were collecting 150,000 flows in peak and 75,000 sustain, you'd still be able to collect that. We're not changing anything there. The question is, okay, if we're able to scale to a particular threshold with the old version, everyone effectively gets that, right? But if there are larger customers that need to scale beyond that point, that's where this notion of multiple collectors that can actually add to scalability, those will probably be charged in the same way that we charge for additional pollers today, where with a particular sort of all-in-one system, you can get some scalability, and as you need more capacity, you buy additional pollers. You'd be able to buy additional capacity with NTA in the same way.
That answers the question. But my use case particularly is I have multiple sites, and right now I'm doing it over tunnels because I can't buy multiple SLX licenses. But that one is powerful enough to do it, but it's sending a lot of data over my tunnels to my remote sites. And I want to be able to put pollers out there, and they're going to be tiny, but I have to pay for a full license.
For a full additional poller.
Yeah,
I got you. Yeah, so that is so it's basically the branch office scenario, and it really applies across all our products. So that's definitely something that we're looking at is how do we give folks the ability to extend remote pollers to different locations and different sites, while at the same time not somehow transitioning customers away from what they would have bought originally. So it's sort of this balancing act that we're trying to do in terms of our pricing and packaging. I definitely understand the problem, and it's a common complaint. And one of the things that at least I operate on just generally is based upon just guilt. Like the more customers that complain about something, the guiltier I feel, and then we tend to move on those things, and that's certainly what motivates me, whether it be features or things that we're not doing that we need to be doing. And that's one thing that we've known about for a while, and that we've got to fix. So we're looking at that.
So guilt.
One of the other biggest products I use in monitoring my network, Splunk, I can throw pollers anywhere, and they're just little agents for Windows, Linux, whatever. They all go back to the main server.
Yeah, they found they've got a different and very interesting way of charging for capacity, which a lot of customers don't like, but that's a whole other
ups and downs
discussion.
with both ways. But that also goes into my next question. When are you guys going to approach Linux?
Sorry, what was the question?
Linux.
When are we going to manage Linux?
No. When are you going to put your product on Linux?
We knew that question was going to ask. Doesn't that get asked every tech field day on SolarWinds? So we do have.
We're saying should it be asked every tech field day?
For that,
you know what?
Yeah, exactly.
You know what?
It's
It's okay if you don't.
Says the guy with the Surface.
I'm okay with that. Thank you.
But I have a Surface too, so I'm with him.
Austin with the Surface.
Once it comes out on Linux, we promise we'll stop asking.
Yeah, of course.
Fair enough,
Yeah.
right?
No, I wouldn't have it either way.
Honestly, I'm going to say this, and it's a little bit of negative feedback, but I depend on NCM as being a mitigating control in my environment. And we're on 6 right now, and I don't know if this has been fixed in 7 or not, but I have the issue of Windows processes getting stuck in NCM. And unless my monitoring team goes in there and checks, I stop getting alerts. And there goes my mitigating control. And that really bugs me.
Yeah, no, we should fix that bug. So I'll add that to my list of things to go
Have
look
a
at.
monitor that watches the monitor.
But
That's what I've been trying to
We
implement.
can
the
tell you
entire
that,
al-
too.
You use non-GEOS or
That's just
something
an
to monitor your other monitoring solution.
I do that.
Yeah.
Yeah. So to the Linux question, I mean that's definitely sort of a pretty broad ask given what we've built on the Orion platform thus far. So I would say that we have products that we've acquired that run on Linux platform, Mac, and we absolutely are committed to sustaining those products on those platforms as long as there are enough customers that justify that. And for the most part, like for instance, Web Help Desk, if you look at vMan or virtualization manager solution, storage manager, we have not touched the fact that we haven't made them Windows only, I guess is my point. For the Orion platform, I would say it's highly unlikely that we're going to make a move to Linux given the size of that investment. I'm not saying never, but we just haven't had enough customers say that we will not buy your product unless it runs on Linux. That may change over time, but we just haven't had enough demand to say we're going to put that kind of investment in porting the entire Orion platform, which is really what a lot of our core products run on, to a Linux-based system, because that would be a huge investment for us. And like I said, I'm not saying that it wouldn't happen, but we haven't had the customer demand to do it yet.
Okay.
Basically, Linux, lots of noise, not paying customers. It's not a free world. It's a small world. It's a Windows world, but it's not a free world.
Watch that.
Wow, I know. Prepare. I think
Go to your office every week to reboot your servers.
I think you might get hit by a belt buckle or something. Yeah, might come flying across the room.
Where's that water bottle from the movie last night?
Hey, Steve Ballmer's going to come out here and throw chairs.
John Smallberry.
Yeah. Now, from a management perspective, we obviously manage Linux systems. We manage a variety of different platforms and vendors. So, and that will continue being a priority. But yeah, what we run on is sort of a more fundamental question. So, unless there's more questions around NetFlow Traffic Analyzer and Fastbit and kind of what we're doing there, wanted to kind of switch gears.
When are we going to see that?
So it's in beta right now. So if you want to see it now, you absolutely can sign up for the beta, and we can get you a copy of that so you can try it out. Just catch me afterwards. I'd be glad to hook you up. We're definitely looking for more beta participants so we can validate one that this performs as well, hopefully better than what we had before. And we're very interested in understanding in real-world environments how much the offloading of that current traffic of NetFlow on the SQL database, or current storing of NetFlow traffic into the SQL database, will have on your Orion environments, because we're thinking it's going to be pretty significant. Because for the most part, one of the things that really drives the sizing of hardware for Orion deployments is actually NTA. So by moving that to a different storage system, we think that's going to make a huge difference. And so, just by that upgrade, we're hoping that a lot of customers see significant performance across the board. So, website and SQL and everywhere else. And it might also allow some customers to look at their SQL deployments and then determine, if they can hopefully apply those cycles to other things once it's not being used for NTA.
On the beta, I would participate in virtually every beta because I own virtually every product, but I have to get Windows licensing for it. So I can't. That's a problem for me is the licensing.
Okay.
And the way you guys do your betas is there's no path from. In some of them, there's no path to production, kind of thing. So it requires me to spin up a whole separate environment just for it.
Right. And so and that's something that we've had a number of discussions internally about is what betas do we allow upgrades? Generally, we try to allow upgrades from in between betas, but it really depends on how much work that is and what the payoff is. We definitely allow upgrades when it gets to release candidate phase. And that's where we're basically, we think we're done. We've done all of the testing that we can possibly do in-house. We've had the betas, and we think that this is ready to go GA, but we want to roll it out to some customers just to make sure that there isn't anything environmental that we're missing before we call it generally available. So, I mean, and to your point, we have customers that are participating at different phases. Some folks, it's no problem for them to go spin up a VM and put the system over there in beta. For other customers, it's definitely more challenging. So, wherever you can participate, we definitely welcome the help.
Okay.
Any other questions about NTA or Fastbit before we move on? Okay, so I wanted to talk a little bit, and again, I'll tag team it with Joel here, about NPM. So how many of you, just by show of hands, are using NPM or have at least tried it, downloaded it and checked it out? Okay, so just a few of you. So within Network Performance Monitor, we have a component called the Universal Device Poller. So that's just basically a fancy marketing name for a custom MIB poller, right? So what it's allowed us to do is, for the basic things that we collect out of the box on every single device, if they follow the standard MIBs, we can actually extend that on the fly, right? So out of bound of a particular release, you can go to the Universal Device Poller, pick the specific OIDs you're interested in pulling those statistics. You can do transformations and you can do calculations on that data. And then you can represent it in our resources and our views and in our reports. So great. The problem is that as you look at that tool, one, it's a Win32 tool, which presents a lot of problems for a lot of our customers in that they have to remote desktop in there, and they don't want to give everyone access to their Orion server and that level of privilege. So that's an issue. But number two is that it isn't quite native support, right? So when you add a universal device poller and you create a custom chart or you create a view or you create a report, it doesn't look like everything else. And you can't necessarily feed into the basic statistics that you'd want to feed into, like for instance, the things that we gather on every single device, CPU, memory, disk, volumes, and those types of things. You can't necessarily say, really what I want to add is this custom device to NPM, and I want that to look native. So I just want NPM to know that I've added this new device and for it to just show up in all the places that data shows up today. And so we're working on a new concept called Device Studio. And it really is the next generation of Universal Device Poller. And I'll show you some mock-ups. They're still very early of kind of what we're thinking there. But the concept is that whether it be customers, whether it be partners, and most importantly, whether it be ourselves, the ability to create native device support for NPM on the fly. So whether it be in a pre-sale situation or whether it be a customer asks for it on Thwack, and we want to go and create a new device because we've gotten enough requests, we don't have to wait for the next release to be able to do that. So that's something that we're working on, and I'll let Joel talk a little about kind of just generally sort of the architectural approach, and then I'll show you a quick mock-up before we go on to the next topic.
So the way we want to be able to do this is, I think one important part is that we want to be able to kind of dissociate the platform of Orion from really kind of all the devices that are supported by that platform. And that means that, in order to do that, we need to be able to package that intelligence that represents a device. And basically that means the information about how to go and grab the data from that device, the alerts that are associated with that device for the values that we know are good to set from the get-go, the reports also, the views, and the what we call the web resources, which basically are widgets in NPM that basically are displaying the data. So we need to be able to package all those things together in something that is redistributable, and that can basically then be shipping, ideally with the product. But if we have to add support for a new device or a customer wants to create a new device, he basically can create that on his own, import that into NPM, and basically then kind of apply that to certain nodes that he has discovered. So what we've been working over the past few years is a packaging system, if you want, very similar to the RPM concept that you have in Linux, where you basically have a package, and you can basically have a dependency chain from that package that says, okay, in order for me to actually monitor this device, I need to have a dependency onto a base package that contains a bunch of building blocks that will basically make my life easier. And so that's kind of the architectural things that we've done for supporting this feature. Now, that's the back-end part of it. A lot of the hard work is making that user experience very easy to use and very simple for people to create new packages, and also applying them to the nodes that they have in their network. The goal also is to expand that past just NPM. NPM is really kind of the first one because we have that need there. The goal is to reuse that technology, for instance, on the storage side, where one of the problems where we have is adding new device support for storage takes a long time right now. So it's really our goal to be able to reuse that same technology and packaging solution for storage devices so that when a new array comes out, for instance, well, either a partner or maybe that array vendor or us or a customer, for instance, can actually create support for that new storage array and kind of deliver it, either to Track or through us and have a way to get that thing out and basically kind of be supported by the product.
Okay. Brandon, would you mind turning on the projector? Will technology work at the time that you need it? That's the question.
It's coming.
There you go. So what I wanted to show, assuming it comes up here, is really just an early mock-up of what we're calling Device Studio. And so I'm just going to run you through just the basic sort of wizard so you can get an idea, because we've been talking in abstract for a while here, on what this actually looks like in the product. There we go.
Yeah, it was the way.
So,
it took me a while.
So one of the first things, if you're going to add any device, or any statistic into NPM, is you have to first choose, what specific OIDs you're interested in, right? And so that's sort of the first phase in this wizard, is to choose your object ID. So we provide an interface which allows you to go and, based upon the type of vendor, it basically filters the OIDs. You pick a particular target device, and it'll actually show you the OIDs that are available from that device. Once you've actually gotten the OIDs that you want to select, and you filter them to the particular type of device, then it's a matter of actually doing something with that data, right? So you've collected a series of metrics. Well, you might want to transform that data. You might want to perform calculations on it before you present it. And then most importantly, you want to be able to provide thresholds on what are good, bad, critical values for that data, so that it will actually inform alerts. And also it will show up in the web console in the right way. So that's effectively the next phase within this wizard, is to configure on a per OID basis, what are those values, right? So you're effectively building a template for what this device will look like. And for those of you who have used Network Configuration Manager or our Server and Application Monitor product, you probably understand that we already have this capability today. On those products, for instance, you can add a new device to back up on NCM relatively easily. You can add a new application to monitor within Server and Application Monitor really easily. So we want to do the same thing for NPM. It's a little bit more complicated because SNMP isn't as elegant as some of the other things that you can do within those products. Yeah, exactly. So it's not an easy, Denny talked about this a little bit, but it's not an easy problem to solve. SNMP polling and custom mid browsers and those kinds of things have been around forever, but solving that in a way that a customer could actually walk through it is no small feat. And so we're again, these are early mock-ups, so I wouldn't claim that we've solved it with these, but these are the things that we're showing to customers and trying to actually have them walk through and figure out where they stumble, where they fall, and then we figure out what we need to do to change and fix that. So once you've actually configured what specific OIDs, what is basically the template you want to build, then you actually want to add it to views. And so this is where we're going to be improving just view management in general over the next several releases. We're going to be improving reporting so that it's much more, I would say, 21st century in terms of drag and drop and those types of concepts. But that's effectively what you would have here, is the ability to add resources. So if I add this device, what sort of data do I want to display on this summary view? So for the overall information, what do I want to display as I drill down to the node, and what shows up there in terms of that data? And then finally, you might want to basically pick which types of nodes you want to assign it to. So as those come up in your environment or discovered, they can automatically be added. So we're replicating a lot of the universalized puller that already exists today, but we're trying to package it in a way that where we can create these things. And so maybe most of you never even have to look at this screen, but we can package these out of band. So for us, it provides an incredible amount of flexibility so that we can have a team specifically focused on adding device support, or we can go to a partner and say, hey, you're coming out with this new device, or maybe they come to us and say, we're coming out with this new device and we want to add support in NPM because we have a lot of overlap between our customers and your product. And so they can just go into this interface and add it on the fly and post it to THWAC, and they immediately become available. And so in the same way that they're available within THWAC for SAM templates and for NCM device templates, you'd be able to do the same thing here. You'd be able to just go pull a list of extensions to your device studio or device kits, and be able to just import those into NPM, and voila, you're good to go. So that's the concept behind device studio and device kits. Any questions about that? Comments? All right. So the last thing that I'll kind of tag team with maybe Joel and Brandon on is DPI. So this is a topic that we've looked at for a long time. So deep packet inspection, where does that fit into the SolarWinds portfolio, and what are we doing around that? So we've definitely as I said, been looking at how customers are using deep packet inspection, how they're using Wireshark as part of their daily troubleshooting flows, and what we've sort of come to the conclusion on now is that is a technology that is ripe for incorporation in our portfolio. We feel like that there are enough people that are certainly using Wireshark, but are also thinking about, we've heard it from enough of our customers where they're thinking about DPI as it relates to how do I really look at network performance in the context of applications, right? And so you can get, there are ways of getting that through synthetic transactions with things like Cisco IPSLA. You can get at latency, but it's only if you own Cisco technology at the endpoints, which a lot of people do, but that can't be the only answer, right? And so we're actually looking at DPI technology now and looking at how we can incorporate that across all of our products. So there are a number of things that we're looking at. The simplest use case that we've heard from customers is, I am troubleshooting within Network Performance Monitor. I got an alert. I've come to the console, and through the amount of data that you guys are collecting, I've gotten it to this point, but I'm still not able to figure out what's going on. So ultimately, my last resort is to go take Wireshark, on my laptop and go into the network segment or tell someone to go do that and get a packet capture in network segment and figure out what's going on. So if you could have that be available directly from NPM, where either with a push of a button, you can start collecting from that part of the network, or maybe it's collecting on the fly when it discovers that there's a problem, that would be awesome. And we would love to have that as part of NPM. That would actually add value. That's something that we can consume because our engineers are already using Wireshark today, so they get that. The other thing that we're looking at is how do we leverage the flow data that we're already collecting, and how do we combine that with the deep packet inspection data, so the packet-based data, to better determine what is sort of the mapping across the board in terms of, if there's a flow that is happening about a particular application, how can we leverage that information we're already collecting, layer on DPI, and figure out that it's actually, this series of flows actually represents this application, and being able to measure the latency at each point of that application. So if the application is represented by this endpoint, which happens to be a SQL server, this endpoint, which happens to be a web server, and then these endpoints, which happen to represent the end users, then show me that. Provide me a visualization of what that actually looks like within NPM, and then allow me to drill in and troubleshoot from there. So that's sort of where we're going around DPI. Now, again, as Denny said, our intention is not to sort of reinvent the wheel necessarily. There are plenty of products which I'm sure you guys have used that actually solve that, but they charge tens of thousands, hundreds of thousands of dollars to get you that information. So our goal is to incorporate that into our existing products so that our customers can just have that and potentially remove some of the the hardware appliances that they've been paying probably as much as they have for the SolarWinds portfolio to have in their systems to collect this data, or ideally have them be able to say, well, I can get this from SolarWinds and maybe not go buy one of those DPI-based technologies to get that same level of data.
So who are you looking to actually sell that to? Because you start basically going beyond network performance management. Now you're stepping into APM type space. That's typically a different person you're talking to than your standard network geek. Is that who you're looking to sell? I ask it from a positioning position just because, as redundant, I ask it from the standpoint of I work for a SolarWinds partner, sell for other APM vendors, and it's on the pre-sale side. It's typically depending on what you're selling. There are different people. Are you looking to start to, I guess, get into the actual APM space on the cheap, as opposed to going to CompuWare and some of the other players out there that are
right? Yeah, and so that's a great question. So I would say with the initial phases of what we're trying to do, we're trying to target the exact same user we've targeted before. So the guy that's using Wireshark, or the gal that's using Wireshark, I guess, that is going out into a network segment and trying to troubleshoot something that needs the packet level data to get to what is going on. Is did someone misconfigure a DHCP server? Is someone is there a virus outbreak or something on this particular set of machines? What is actually going on? And maybe all that information isn't available in NPM today. And so eliminating that extra step they have to take. Now moving forward, I agree. I mean, you start to blur the lines of, and I think this is starting to happen. At least this is sort of we see among the customers that we've talked to, is that there is this sort of level of convergence where before you always had is it a network problem or is it an application or a server problem, and those two guys would fight it out. And I think that more and more we're starting to see that people want sort of a unified view of that, and the notion of whatever you want to call it, end user experience monitoring or user experience as a measure of whether or not things are up or down or whether they're really performing, because you can go look at the individual components and say, yeah, that's good, that's good, that's good, is becoming more and more important to, I think, the network folks as well, to understand that. And especially, even if you're responsible only for the network, to understand, what the implications of bad network performance are on the applications, right? So being able to look at latency and those types of things from these two different points and say, well, the difference between those two things is actually the difference in this application and these end users actually being able to reach it, or it's their ability to go and actually pull up this order entry form in an efficient manner. And I think there still may be some handoff where they're just like, okay, it's not a network problem, it's an application problem. But I think the level of granularity they're looking to go to has changed. And so the sophistication expectations have changed. And so we're trying to sort of meet that, what we think is kind of maybe a new minimum bar, as well as there are customers that aren't SolarWinds customers that are currently looking at those types of solutions. And we think that some of them are on the periphery of the people that we talk to anyway. So can we pull some of those guys in at the same time?
That's fair. Could I ask you? You mentioned, I guess, looking at getting into the with people using Wireshark, this notion of being able to kind of remotely capture data and then grab it and perform DPI, whatever you're going to do to merge that with flow data. How are you looking at doing the actual remote capture? I mean, that can get very, very expensive if you're looking, to incorporate, taps or things like that. Are you looking for some way to, maybe a couple of years down the road, we're going to have a way to just remotely spin up an actual monitoring session on a switch, dump it locally to a file, and you can do that to a certain extent today. But obviously, you want to serve more than just, Cisco. right? So you got to give people options. I'm just wondering, kind of, if you thought about or how you're thinking about actually making that happen.
Yeah, I mean, again, I think that's one of the things that where it's one of the reasons why we've avoided this particular problem, because that is, you know, a lot of people, we've done surveys of our customer base because we were really concerned about this problem, like how many people can actually span a port, right? And how many people can actually go and or even know what spanning a port means, right? In a Cisco environment, or doing port mirroring on you know, other switches, and so surprisingly a large cross section of our customers, you know, can do that no problem, right? They said, you know, it's something that if they're vaguely familiar with, but that they could learn, and so that gave us a little bit more confidence in terms of what we might be able to do there, but. You know, in terms of, you know, how we plan on solving the remote pro problem, this is where, you know, I think, you know, to the Linux question, I think all things are on the table right now. So I don't want to pretend like we've sort of figured that out yet, but, you know, a Linux-based virtual appliance or something like that is definitely on the table as something we might consider, where, you know, you go and not hardware appliance, but, you know, a software appliance that you can go and configure on a remote site and span a port to it, and so that when you want to start capturing traffic, or maybe you have it capturing traffic all the time, we can collect that information and be able to roll that up into NPM, and so you can have these different probes throughout your network. I think we'd also look at, are there opportunities to leverage the existing hardware you already have, where they have the ability to deploy, you know, small virtual machines to do things, assuming they have access to that same information, and seeing if we can leverage those, which I know there are a number of vendors that kind of do that for the appliances that they own, where they leverage them as probes. So I think we're still looking at exactly how we do that, but our goal is to make it, you know, we have to make it so that the evaluation experience makes sense to our customers, and that, you know, the normal IT guy can actually go and configure this.
Okay. Yeah, I guess and you either have the always on, always dumping, you know, doing the whole kind of circular, I guess use the term buffer, just at any point in time there's X amount of data, or
right.
I guess when you mentioned it the first time, I was thinking of the standpoint of that you're not actually shooting any sort of a span or a tap at the present time, and you're just going to go and instantly spin it up and then start, because it could be any number of, say, a remote switchboard or any number of circuits that I want to start capturing on, you know, hardware limited monitoring sessions available on various platforms. And so I was thinking from a standpoint of automating, and I hesitate to use the word software defined or orchestration or anything like that, but
throw something at them. I think we can do both. You know, I think we can certainly do the kind of black box approach, where, you know, you keep the last 15 minutes of the traffic that was seen on that tap. The benefit that you have with that is that if there's an error, at least you have some evidence that you can potentially attach for some of the alerts that we trigger, you know, with that data. That doesn't solve everything, but then you've got the other one, which is the just-in-time. Okay, there's a problem right now. I don't have data. How can we automate that, you know, triggering of, you know, let's try to get to that data, the tap or whatever it is needed, you know, and I think really we need to address both to actually be, you know, covering all those use cases. And we're thinking about both. I think the other thing that is interesting there is that right now you've got all the vSwitch traffic, for instance, that, you know, is kind of invisible, you know, to a lot of tools. And this gives us a great way also to get, you know, intra-VM communication, for instance, on a cluster, for instance, things like that, where, you know, they don't have a 1000V or something like that that can be spanned. Well, that's a great tool for us to get that data as well. And so as we are looking at DPI, what you're going to see is that we are certainly talking about it right now in terms of NPM and NTA and those tools. We are looking really at this as a data source that basically will be available and disseminate data to basically all the products, you know, pretty much all the products in our portfolio.
But you're looking to not just be, again, to go back to your message from earlier, not be data center centric,
yeah.
Right? Because otherwise it's, just slap a VM somewhere out there that, or some kind of shim into the virtual nebulous dealy, and start capturing.
Can I caption that, please?
Well, yeah,
Trademark that?
go for it. You can have it. But obviously, there's an equal number of problems on the edge out there where
Yeah.
real people have devices plugged into things that, even running at 100 meg can still blow things up.
Yeah, exactly. And so yeah, and as Joel said, our hope is to solve for both of those, and to choose a technology approach that allows us to deploy it in a manner where,
You don't want to sell hardware,
yeah, we don't want to sell hardware. Yeah, exactly.
but you do have the same color as Gigamon.
Well, it's difficult to download the hardware, I mean, I know they have 3D printers now, but it's still going to be a little while before you can actually get circuits that actually printing.
Well, maybe wireless will save you on the edge. Remote AP capture is a reality for so many. I don't know.
Yeah.
Maybe we should just rip out all the wires. It's a thought.